Hi there, welcome to the third example of the usage of Laplace transform in circuits. So as always, let's draw our circuit. So we're gonna have a generator, plus minus, then we're gonna have an inductance, then it's gonna be split here, and we're gonna have another inductance, and then a resistance. I'm gonna connect it down here. There we go. But here I'm gonna add resistance in the middle. There we go. So Pg of t. So the generator is actually gonna be 12 volts. The inductance is gonna be 1 Henry. This other inductance is gonna be 0.75 Henry. This one is gonna be 3 ohm. This resistance here is gonna be 4 ohm. And the current flowing is gonna flow this way, and so these are gonna be our I1, this one is gonna be our I2, and this one is gonna be our I. Okay, so let's just say that the circuit has V0 of t equal to 12 volts for t less than 0, V0 of t equal to 0 volts for t greater than 0. Find I of t. Assuming that the circuit is operative at t equals 0 minus. So since we are actually assuming that well, the problem just said assume that the circuit is operative at t equals 0 minus, the circuit is actually going to be easier when we are going to find the current, because we can just consider the circuit without those two inductances. So basically what we're going to say is that, okay, just to find the current, so the total current I, let's suppose to write this circuit instead, this equivalent circuit instead. It's not the equivalent circuit of Laplace, is another circuit. It just, it's basically the same, but we're going to use this one to find the current I. So we can actually rewrite it like so, with just the two resistances. So this one and this one. So this is going to be our R1, 4 ohm. This is going to be our R2, 3 ohm. The current is flowing here, so this is going to be our I2. And if current is flowing here, so this is going to be our I1. And of course, the generator is still 12 volts. Okay, so now we can say, okay, let's find the first current. So basically I1. So I1 is going to be 12, so the voltage, over 4, which is the resistance. So 12 over 4 is 3 amps. So this is I1. So with I1, I really means the current flowing through here, those two ones. And this is going to be our I2, so the current flowing here are these two ones. I2 is going to be 12 over 3, just like R1, but this resistance is 3. So 4 amps. Therefore, I is I1 plus I2 So 3 plus 4, which is 7 amps. Okay. This was just the starter. We're not at the main course yet because we haven't been drawing the Laplace equivalent circuit yet. This was just to find the total current I. So now we're gonna draw the equivalent circuit of Laplace. So in the equivalent circuit of Laplace, my inductances, so those two, are actually gonna be resistances. And those two resistances are still gonna be resistances. So, but keep in mind that it's gonna be slightly more complicated now, because since everything is split, because it's split between here and here, we're gonna have two generators, which we're gonna deal independently, and I'm gonna explain everything just a little bit. So now we're basically gonna have in the equivalent circuit of Laplace these, which is 1, so S, which was 1 Henry, so the inductance just became a resistance. So 1 Henry, 1 times S is S, so just S. Sorry about that. Sorry. This one is a generator which we're gonna consider with minus and plus. So here in the middle, it splits. I think that's the resistance. And here we're gonna have the other inductance, which is 0.75 S, which we can actually rewrite as 3/4 S. And then we're gonna have the other end of the generator with a minus plus. And then we have the resistance, which is still a resistance. So this is 4 ohm, R1, 3 ohm is R2. This I of S, so basically the problem is asking us to find these I here. So this is gonna be our I of S. And the generator over here is gonna be 7 volt and 3 volt because it's split. So now we're gonna do the same thing to find I of S, which is gonna be a little bit more complicated because of the configuration of the circuit. Because we're gonna have V of S minus 7 over S plus V of S over 4 plus V of S plus 3 over 3 plus 3/4 S equal to 0. Just like we did the other in the other examples, but slightly more complicated because of the thing that is split and of the calculation and so on. So this actually gives us this gives us I'm just gonna jump to the result. 48S plus 12S squared V of S times 3s squared plus 40s plus 48 minus 336 plus 36s, everything over 48s plus 12s squared. So our v of s is actually 336 plus 36s over 3s squared plus 40s plus 48. So now we have to find I of s, because from I of s then we're going to go to I of t, but I of s is actually v of s over r1. So basically I of s is going to be 336 plus 36s, all those things, over 3s squared, sorry, plus 40s plus 48 times, because I'm just, it's supposed to be divided, so I'm just flipping it and multiplying instead. So times 1 over 4, which gives us I of s equal to 84 plus 9s, everything over 3s squared plus 40s plus 48. Okay, so yeah, from here we have to go on and basically find the I of t. So in order to find the I of t, we have, as like before, we have to find the roots of these, which actually looks ugly, but it's not impossible to do. So as always, you can use delta if you want to, but let's try to simplify things a little bit and make our life easier. So I of s, well, we can just say, okay, well, let me just do this one. So 84 plus 9s over, let me just do 3 times s plus 12 times s plus 4 over 3. Because I just broke this one into those 3 guys. And now that I have this 3 in front of everything, I can say, okay, I can get rid of these 3, which becomes a 1. And 84 divided by 3 is going to be 28. And 9 divided by 3 is just going to be 3. So I of s is actually 28 plus 3s over s plus 12 times s plus 4 over 3. So this is our I of s, and those two are the 2 roots. In fact, we can say that s is equal to negative 12 and s is equal to negative 4 over 3. Now we're going to do the same thing, just like before. We're basically going to say, okay, and apply the clever trick in order to find the poles, now that we have the roots and I of s. So, yeah, I'm going to have to rewrite it, just to make, let me just rewrite it. We said I of s was equal to 28 plus 3s s plus 12 times s plus 4 over 3. So the two roots are s equal to negative 12 and s equal to negative 4 over 3. Okay. Okay, so now we're going to do the same trick as before. So we're basically going to multiply the numerator by this one, and then we're going to substitute this value of s in order to find the first pole. And then we're going to do the same thing, but with this one and this one for the second pole. So the first pole is actually 28 plus 3s times this guy here. So s plus 12, everything over those two guys. So s plus 12 times s plus 4 over 3. So as always, those two guys cancel, and I end up with a mess. No, I'm joking. So 28 plus 3 times negative 12 over negative 12 plus 4 over 3. I just substituted negative 12 s with negative 12. So 28 plus negative 36 over negative 36 plus 4, everything over 3. Mine, just simplify this fraction here. So what do we get? Negative 8 over negative 32 over 3. So this is actually negative 8 over negative 32 times 3. Because when you have a number divided by a number divided by a number, you can just multiply this number and bring it here. So I have negative 24 over negative 32, which is just 24 over 32, which is just 3 over 4. There we go. So this is our first pole. Now let's do the same clever trick to find the second pole. So we're going to have the numerator as before, so 28 plus 3s times this guy here, so s plus 4 over 3, everything over those two guys here, so s plus 12 times s plus 4 over 3. So as always, those two guys cancel out, and I end up with 28 plus 3 times negative 4 over 3 over negative 4 over 3 plus 12. Just substituted s with negative 4 over 3. So, well, those two guys cancel out, and well, I end up with 28 minus 4, everything over 3 negative 4 plus 36. Okay, so this is just 24 over 32 over 3. So same thing as before, number over a fraction, so number over number over number. You can just say, okay, number over number times this one brought here. So I basically get 24 over 32 times 3, which is 42 over 32, which I can simplify as 9 over 4. So those two are our two poles. So this is almost over. Now we just have to apply the anti-transform of Laplace in order to go from I of s to I of t. So I of t which is required by the problem, just the anti-transform of Laplace of I of s. So this whole thing here. So the anti-transform of Laplace of 28 plus 3s over s plus 12 times s plus 4 over 3. So I of t is actually, well, 3 over 4, which is the first pole, e to the, well, the first root, so e to the negative 12 times t, so negative 12t. Then we're gonna have, we would have minus, oh no, plus, because the second root is positive. So plus 9 over 4 e raised to the power of, well, negative 4 over 3 times t, so negative 4 over 3t. So, as I said, negative 4 over 3t. And that's it. This is the anti-transform of Laplace of I of t, so this is just of I of s, so this is just I of t. And once again, we have applied Laplace and solved the circuit using the Laplace transform.